Hello guys, I am Daisy D and my topic is disk scheduling algorithms. In operating system, seek time is very important. Disk scheduling algorithms are used to reduce the total seek time of any request. The purpose of this material is to provide one with help on disk scheduling algorithms. Hopefully, with this, one will be able to get a stronger grasp of what disk scheduling algorithms do. The types of disk scheduling algorithms are FCFS, first come first serve, SSTF, shortest seek time first, elevator, scan, circular scan, C scan, look, C look. There are six types. First one, FCFS. It is the simplest of all disk scheduling algorithms. In FCFS, the requests are addressed in the order they arrive in the disk queue. Advantages are every request gets a fair chance, no indefinite postponement. Disadvantages does not try to optimize seek time, may not provide the best possible service. Example, we have the order of request as 82, 170, 43, 140, 24, 16 and 190. And we have the current position of head as 50. So first we have to draw a number line starting from 0 to 199 as the starting and last ending point. And then we'll mark all the requests which are given in the ascending order from the smallest to largest. And the head is marked in its position. 50 is marked. Now we'll start. So starting from the head, we have to start from the head. So starting from the head, 50, and then it goes in the order the request is. First we have 82 in the request, so it goes to 82, and then next to 170, yeah, and then 43, then 140, then 24, 16, 190. That's it. So this is the simplest of all the algorithms in disk scheduling. So the total seek time is, we have to calculate by now first one, it goes from 50 to 82. So just minus 82 minus 50. That will get the time spent. Next plus next one, 170 minus 82. Every time we have to do with the larger number minus the smaller number. So we'll get the total time spent. So when we do this for all the things, we get 642 tracks. Now total head movements is the total seek time divided by the total number of requests. We have 7 requests here. So total is 642. So 642 divided by 7. We get 91.7. So it is written in cylinders. Next, SSTF, shortest seek time first. In this, the requests having shortest seek time are executed first. So the seek time of every request is calculated in advance in the queue, and then they are scheduled according to their calculated seek time. As a result, the request near the disk arm will get executed first. Advantages: average response time decreases, throughput increases. Disadvantages: overhead to calculate seek time in advance can cause starvation for a request if it has higher seek time as compared to incoming requests. High variance of response time as SSTF favors only some requests. Example, you have the same question and the current position of head is 50. Yeah. Now every time it starts the timeline, okay, we draw the timeline and we'll start marking from the head. So starting from the head 50, we have to check the smallest um, request. So come, you see, we have two numbers to the left and to the right. So compared when 50 is there, compared when we compare the smallest one, 43 is nearest, 82 is far. So the smallest and the nearest one is 43. So it goes to 43, and then to 24, 16, and then goes to the opposite direction to the larger values. So the total seek time is Same thing, similar way we have to calculate the larger number minus the smaller number. So we'll get 208 tracks. Now the total head moments is 208 by 7, that is 29.7 cylinders. Next, scan. In scan algorithm, the disk arm moves in a particular direction and services the requests coming in its path, and after reaching the end of the disk, it reverses its direction and again services the request arriving in its path. So this algorithm works as an elevator and hence also known as elevator algorithm. As a result, the requests at the mid-range are serviced more and those arriving behind the disk arm will have to wait. Example, same question, and we have the head as 50, and it is also given that the disk arm should move towards the larger value. Starting from the head 50, it goes to 82. First, it covers all the larger values and then goes to the smaller values. So the total seek time is, first we'll take the larger value. If we see, the starting one is 50 and the larger side, the last one is 199. Here it goes to the end of the track, that is 199. It goes there in scan algorithm. So we'll take 199, the last value, 199 minus the first one, 50, plus this side, the next to the opposite direction. If we see 199 minus 16, so we take only these two, then we get 332 tracks. Then total movement, head movements, is 332 divided by 7, that is 47.4 cylinders. Next, C-scan. In C-scan algorithm, the disk arm, instead of reversing its direction, goes to the other end of the disk and starts servicing the requests from there. So the disk arm moves in a circular fashion and its algorithm is also similar to scan algorithm and hence it is called as C-scan, that is circular scan. Advantages: provides more uniform wait time compared to scan. Here we have the same example and the head start is at 50 and it is also given that the disk arm should move towards the larger value. Starting from 50, it covers all the larger values: 82, 140, 170, 190, 199. And then it goes to the other end. It doesn't go to the smaller value. It goes to the opposite end. That is, it goes to 0 from 199, the opposite value. It goes to the last, to the first value, that is 0. And then from there, it goes to all the smaller values, that is 16, 24, and 43. Here, the seek time is calculated by same thing from first to end. So 50, it starts from 50, 199. So 199 minus 50, and then the straight one, that is 199 minus 0, and then the last one, 43 minus 0. So we get 391 tracks. So the total head movements is 391 divided by 7, that is 55.8 cylinders. Look, it is similar to scan disk scheduling algorithm, except for the difference that the disk arm, in spite of going to the end of the disk, goes only to the last request to be serviced in front of the head and then reverses its direction from there only. Thus, it prevents the extra delay which is occurred due to unnecessary traversal to the end of the disk. So here, look, same values with this head as 50, and then the disk arm should move towards the larger value. So it starts from 50, goes to the larger values, and then here in look, it doesn't go to the last. It covers only the requests which are given. It goes till only till 190. It doesn't goes to 199. Only in scan and C scan it goes to the last values, that is till the end of the track, that is 199 and 0. But in look, it doesn't goes to the end of the track. It covers only the given requests. It goes to 190 still the end towards one direction, and then to the opposite direction it goes to 43, 24, and 16. The seek time is calculated by 190 minus 50 plus in the opposite direction it is 190 minus 16. So total is 314 tracks. Total head movements is 314 divided by 7, that is 44.8 cylinders. CLOOK. As look is similar to scan algorithm, similar way, CLOOK is similar to C-scan algorithm. In CLOOK, the disk arm is, in spite of going to the end, goes only to the last request to be serviced in front of the head, and then from there goes to the other end's last request. Thus, it also prevents the extra delay which occurred due to unnecessary traversal to the end of the disk. Example, same values with the let's start 50, the disk arm should move towards the larger value. Yeah, here it goes. Same, it is similar to C-scan. It goes to the it goes to one direction towards larger values and then goes to the opposite. It goes straight to the smallest value, that is 16, and then from there it covers all the smallest values, that is 24 and 43. The seek time is calculated as 190 minus 50 plus 190 minus 16 plus 43 minus 16. So we get it as 341 tracks, 341. The total head moments is 341 divided by 7, that is 48.7 cylinders. Thank you.